here we start looking at how to find the domain of a function. And in particular, we're going to focus on three distinct types of functions: polynomial functions, rational functions, and then we'll also go ahead and look at radical functions. So to begin, polynomial function, our favorite functions, look something like the following. So you could have a linear function, a quadratic function. Polynomials also include cubics, quartics, and beyond. And these are one of our more favorite functions because these functions have no domain restrictions. So if we have no domain restrictions, anytime we're working with a polynomial function, we automatically know that that function has a domain of all real numbers. I want to point out here that a domain of all real numbers in interval notation is written as negative infinity to positive infinity. The next type of function we need to explore are rational functions or fraction functions. So some examples of rational functions include y is equal to 1 over x squared minus 25, and f of x is equal to 7x divided by x squared minus 7x plus 12. Now, when working with rational functions, we need to be a little more careful because these types of functions are undefined when their denominators, or this bottom, is equal to 0. So since we know that these functions do not exist, if that denominator is 0, we need to make sure that we prevent these zeros of the denominator from occurring when finding the domain. So to find the domain for a rational function, we always want to keep in mind that we are going to set that denominator, that bottom, not equal to 0 and solve for x. Once we have these x values, we'll then want to exclude them from the set of all real numbers. The third type of function that we need to look at are radical functions. And now, radical functions can be split into two distinct sections: even root radicals and odd root radicals. So functions that are even root radicals include the following. So an example of an even root radical is our good old friend, the square root function. And notice here, our typical notation, we leave that radical pocket blank. But keep in mind, when you see a function like this, that means that there is a 2 in that pocket. Another example is the function f of x is equal to the fourth root of x minus 7. Now, these functions we need to be careful of when finding the domain because they have domain restrictions. So we want to keep in mind that even root radicals like the square root do not exist or are undefined when the radicand or inside is negative. So how do we prevent this from happening? So to find the domain of an even root radical, we want to keep in mind that we need to set that inside or the radicand greater than or equal to 0 and then solve for x. Now, odd root radicals are like polynomial functions. Examples of odd root radicals include things like the cubic root, or y equals the third root of x, or f of x is equal to the fifth root of 2x minus 5. And we say that odd root radicals are like polynomial functions because these functions have no domain restrictions. So since odd root radicals have no domain restrictions, we can automatically conclude that the domain of odd root radicals will always be all real numbers.